Alright, to start, I'm going to press Windows R and type in CMD, hit enter to open up my command prompt. Then I'm going to change my directory into my tutorials where I'm going to store my code. I'm going to make the directory Game Engine, and then I'm going to type code Game Engine to open up this folder in VS Code. The folder directory for this is going to be src, which is our source folders, as this is going to be with all of our libraries, as it's a game engine. We're going to create a new folder, include, and another one, lib. And these will also house our SFML files. So I'm at SFML, click download, then 2.5.1, and I'm going to download the 32-bit for MinGW, making sure it's MinGW, as that's what we're compiling with. SFML should now be downloaded, so I'm going to press Windows E, and that's going to open up File Explorer. Then I'm going to click on Download, so we can see it's downloaded here. Extract, and I'm going to extract it here. Then I'm going to open up the folder, and we can see include that matches, lib that matches, so we're just going to copy over what's inside. To select all the files, I press Shift, click on the top one, and then hold down Shift, click on the bottom one, then you can drag them over. Alright, now we almost have SFML set up. So you can see, here's all the lib files of SFML, and here's our include. The last thing we'll need is the DLLs. So the DLLs will be in the main folder under bin. And let's select all of them, drag it over. So the reason why we need these DLLs is the executable will be looking for these DLLs, and if it cannot find them, it cannot run SFML. So this is where our executable will go. So now we're on to creating our game engine. So let's go to include, new folder, GE, and our game engine will consist of only HPP files. So we will only have it in include, we won't need anything in lib. New file, I'm going to do ge.hpp, and this is our first file. Now hash if and def, this will be ge_hpp, and then we'll go down here and define ge.hpp. What this means is if it can't find ge.hpp, it'll create everything below. Otherwise, it's already been created, so it doesn't need to create it again. And now we'll press Ctrl-Shift-P, open up Command Palette, go to C/C++, Edit Configurations UI. Set our compiler path to be MinGW, as that's what we're using. And then making sure our include path has workspace folder, so that way SFML will be recognized. We'll go back to our game engine. We can close out of this. Hash include, and then SFML / graphics HPP. Namespace GE. Namespaces you can think of kind of like folders. If we want to access something in here, let's say a class, we can say GE:class, and our class is named temp. And so it has 2 colons there. Struct data, and that with a semicolon. This will hold everything that the game engine will be using, such as the window or states. Let's add the window, SF, render window, window. And now we'll also want a clock. So SF, clock, clock. And that's all we'll have in here for now. We will add onto it the more we add onto the engine. And now we'll write the game loop. So inline void run, and we'll capitalize that and take a pointer to data as a parameter. Now, one thing we'll want to understand is in order to have animations work properly and not have some computers outperform others, we'll want 60 times per every second to update. or we can predefine how many times per second we want it to update. So let's add that. We'll put this up here, float updates per second, and we can leave these all caps, and set that equal to 1.0f divided by 60.0f, and that should be 60 times every second. Now, in order to get this to work, we'll want to add some more variables. We will have float delta time. We can set this equal to our clock, so data arrow clock dot get elapsed time dot as seconds. This will get what its current time is as seconds. And then we'll have float new dt, can set that equal to 0.0f, and elapsed, and set that equal to 0.0f as well. Now, since we have the variables set up, we can actually write our game loop. So we can say while data arrow window dot is open. So while our window is open, we'll want to continuously loop through the game. So we can say new dt equals data arrow clock dot get elapsed time dot as seconds, and then have our elapsed time be the summation of the difference of our new dt and the original dt. So when this first runs, dt is assigned to its current time. Then it has to go through all of this. Once it hits all of this, the new delta time will be added, and this should be a different time as it takes time to compute what's going on here. And then elapsed time gets added, that little increment. And then we need to reset delta time to new delta time, so that way it's continuously getting the current time, then running through everything, and then getting that updated time for how long it took to update, and adding that to elapsed. The last thing we can do is say if our elapsed time is greater than updates per second, then we can know we can update here. So we can say update, and we'll set elapsed minus by equals updates per second. And the reason why we don't set it to 0 is if elapsed is greater than updates per second, and we can say greater than or equal to. If it's greater than or equal to updates per second, we don't want a weird time shift. We can have our render function. So we can render as much as we want. We can draw to the screen as much as we want. And this won't mess up animations, as the animations will be affected by the update, not the render. So here we can say data arrow window and then dot clear. So we'll clear the screen, and then data arrow window dot display. And this will draw everything that we've added right here. So in the future, we'll have a handler, and we'll say handler draw. And that will draw everything, and then it will display it to the screen. And this is our main game loop. We won't add the ability to close next, as we will be making a full screen application. If you want that ability, they have a great tutorial for it in SFML. Now let's build the ability to actually open a window. So we'll say inline void create window. And this will take our data pointer. It will take a unsigned int width and an unsigned int height. And we can also have const char star title. And all a const char pointer is a string. Now, width and height will be very important for calculations that we have. So let's add that right here. Let's say unsigned int width and unsigned int height. Now we'll assign the width and the height to our struct right here. So data arrow width equals width, and data arrow height equals height. And then we can create our window. So data arrow window dot create SF video mode, and this will take width and height, then our title, and SF style full screen, as we'll want it full screened. Then make sure everything's saved. So we almost have this completely finished. One thing we need is a state manager in order to have these updates and handlers actually happen. Currently, it won't do anything. So let's create our state manager. And for that, we need states. So new folder, state. In here, we can create a new file and call this state.hpp. And we will create a parent class. Hash if and def state HPP. Then we'll define it, hash define state HPP. And then our namespace, which is GE. And now we will create our state. So class state. And here we will have public. So we want these all to be public. And virtual void update equals 0. And that needs parentheses and semicolon. We can copy that and paste it and have this be render. So every child of state must have an update function, and it must also have a render function. And because this is a class, we need this to end in a semicolon. Now everything's happy. Now let's create the manager. So new file manager.hpp, and here we can say if and def manager hpp, and then define it. One thing to note is you can also say hash pragma once and you don't have to do all of this. However, I prefer this way. Now we can do our namespace, GE, and let's create another namespace and call this state. In here, class handler, and that with a semicolon. Now, handler will have some public methods. We'll want to update our handler, what's going on, and also to render it. Both of these need to be void. And we can also have them have curly braces to start with, as we'll be writing it in here. We'll want a constructor and deconstructor, so handler, and then tilde handler. There's our deconstructor. This is run on object creation. This is run on object deletion. Now we'll have just a couple more methods. We will have void add state, and this will take a state, so we'll need to include the state up here. Hash include state.hpp. So now we can say state star state, and we will add our state there, but we don't have anything to hold the states yet. So let's continue writing just the basic outline. We will have void remove state, and this won't have anything as parameters. And we will also have void clear state, and that won't have parameters either. Now, we'll want to store this in our private variable section. So we will be using a vector for this. Let's put that up here. Include vector. So standard vector, we're going to store it as a state pointer. We can call these states. Now, a pointer just makes it really easy to create and delete variables. So that's why we're using pointers. Also, I really like pointers. For the add state, we can simply say states.pushback, and then our state that we want to push back. And for remove state, we can say delete states.at, and then this will be our states.size -1, and then we can just remove it from the vector. So states.erase, and this will be states.begin plus states.size -1. And this is how we remove things from our vector, is we get the pointer to the beginning of the vector, and then we get whatever size we want it to be. So if it was the first element, we would just say +0. Since this is the last element, we'll say states.size -1. And one last thing we'll probably want to do is to check to see if our states are empty. So if states.empty, and we can just return this here. And as it's void, we don't need to return any value. We can just say return. So that will error check if the states are empty. It won't delete from it because it can't, because they're empty. Otherwise, it will. Now here in clear state, we will want to clear the states, as it says. So we'll iterate through each state. We'll say for state pointer, and we can call this state in, and this colon basically means in states. So each state in states, we can then delete that state. And that will delete all the states in our vector. Then we can just clear our array, or our vector. So states.clear. Awesome. For sake of spacing, I'm just gonna enter there and there. Now when this class is deleted, we'll want to delete all the states in states, and we already have a function to do that, so we can just call that function. We can say clear states. And we can add an S here just to be more grammatically precise. Now for update and render, this will be very similar to our deletion, except for instead of deleting, we'll just update them and render them. So here, we'll paste that in and do the same thing here. Instead of delete, we can say state arrow update, and that's not an arrow. And then state arrow render. And this will update it every single state, and this will render every single state. And now let's go to our state class and add in our manager below. So hash include, and this will be our manager. .hpp. That way we can just include the state file, and it will also include our manager. So if we go back to our game engine, we can now say hash include states, or state/state.hpp, and we will have access to our manager as well. One thing to note is inside manager, we say handler here, so let's actually change the name of this to be handler. And we can change that in here as well. And we should also change the if and def. All right, back into game engine. We now have handler, so we can say here our state handler, and we can call this state, and we can just close it with a semicolon there. And here we can now say data arrow handler, or state arrow update, or not arrow, dot update. The reason why we use arrows is because data is a pointer. Every time you use a pointer, you use an arrow. Every time you don't use a pointer, you use a dot. All right, and then we can change update right here to data arrow state error or dot update. And hopefully everything is happy. To finish off this video, let's just test it real quick. So let's create a new file, call this main.cpp. We can say hash include and then ge/ge.hpp, and then create our main function. So int main return 0. Now we'll want a state to actually see states being handled. So let's create a state here. We can say class, and we'll call this temp because it's temporary state. We'll delete this in the next video. And class temp is a child. So let's have it be of ge colon state. And so this also needs to say public because the parent class is public. Now we can have public and end this with a semicolon. In here, have update and have that just not do anything, and then render and have that not do anything either. Then inside main, oh, these need to be void. Inside main, do ge and then data. Let's create our game data, call it just data. And we can set that equal to new ge data. Then inside of the game engine, we actually want to create the window. So we'll say ge create window. Now we'll throw in data. Then we'll add our width. Let's just give it 100. Actually, let's, because it's full screen, give it our real width. So 1920 by 1080. And then the title, we can just call this temp. Last thing we'll need to do is to start up the, to add the state, then to start up the actual main loop. So let's start up the main loop down here, ge run, and throw in data. We'll leave updates per second as it is. And let's now create, or let's add temp to our state manager. So ge and then, or data arrow, and this will be state dot add state, and inside state we will want to put a new state. So new temp, and that will create our state temp. Awesome. Everything seems to be happy. One thing to quickly fix is in the game engine, this was a plus. I typed it as a plus. It should be a minus. And instead of update here, this needs to be render. Now let's create a temporary makefile. So makefile. In here we can say all compile and then link. So to compile it, so compile, this will be g++ dash I for include, and this is our include path. So that's just src slash include, and then dash c and our file, so main.cpp. And then for link, we will say g++, and this will be main.o dash o, and then our executable name, so main dash l, this is where our lib folder is, so src slash include or slash lib, and then our linked, dynamically linked library, so dash l SFML graphics dash l SFML dash window dash l SFML dash audio and dash l SFML dash system. And let's see if that compiles. So now we can come down here and say make. All right, we have an error. That's because this has a lowercase f. So let's go in there real quick, fix it up. Put capital F there, and let's try making it again. This S needs to be lowercase as well. Whoops. All right, so now we have an executable here, and we have a main.o, so let's try and run it. Main.exe, and we've got a black screen, and this is the window running. It's full screened, so we don't have a little X. You can see GeForce thinks it's a game, so that's kind of cool. And the window creation and game loop are currently working. So in the next video, we will probably start off making a platformer game using what we have, and we'll be adding to the game engine as well as writing the actual game code. Thanks for watching. Hope you have a stellar day.